In this question, we are given two identities of whole numbers. We are required to generalize the two identities. Now let's look at the identities in some details. The first identity is about the number 2020. We have 2020 squared plus the next whole number squared. By the next whole number, we mean 2021. 2021 is the next whole number after 2020. And then plus 2020 squared times 2021 squared equals some whole number squared. The next identity is very similar. You have 2021 squared plus the next whole number squared. Again, by the next whole number, I mean 2022. And then 2021 squared times the next whole number squared equals some whole number squared. To generalize the two identities, we use n to denote a whole number. And then we claim n squared and then plus the next whole number squared. The next whole number is n plus 1, of course. And then plus n squared times the next whole number squared. We want to show this expression is a perfect square. By a perfect square, we mean a whole number like 1, 4, or 9, which is some number squared. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. Again, we want to show the expression in line 1 is a perfect square. From line 1 to line 2, we just expanded n plus 1 the whole thing squared. Using the formula a plus b squared equals a squared plus 2ab and then plus b squared. For the second term in line 1, if we treat n as a and treat 1 as b, so we have a plus b the whole thing squared equals a squared, which is n squared, plus 2ab, the factor of 1. B value is 1, the factor of 1, I do not have to write the factor of 1. And then we treat this 1 as 1 squared. All other terms are copied from line 1. From line 2 to line 3, I just rewrote n squared plus n squared as 2n squared. All other terms are the same. From line 3 to line 4, we just wrote the terms in slightly different order. We brought the last term to the front. From line 4 to line 5, you look at these two terms in line 4. From these two terms, we took out a common factor of 2n. After taking out 2n from 2n squared, there remains n. And after taking out 2n from 2n, there remains a factor of 1. Again, from these two terms, we take out a common factor of 2n. We have 2n times n plus 1. All other terms are copied from line 4. And then from line 5 to line 6, we used a property of exponents to write the first term in the form of some whole thing squared. If you treat n as a and you treat n plus 1 as b, then use that formula, you can rewrite the first term in line 5 as the first term in line 6. From line 6 to line 7, if we treat the whole thing in the square brackets as a whole, we have the form of a squared plus 2ab and then plus b squared. We treat a to be the whole thing in the square brackets, and we treat b as 1. Using this formula, we can write line 6 in the form of a plus b the whole thing squared. At this point, we can see the expression in line 1 is indeed some whole number squared. So the expression in line 1 is a perfect square. The last step is just try to get a little bit more organized. We write the expression inside the brackets in some nicer form. To summarize, for any whole number n, the whole number squared plus the next whole number squared, then plus the whole number squared times the next whole number squared is a perfect square. Specifically, It's n squared plus n plus 1, the whole thing squared. At this point, we have done the question, but we do want to convince ourselves the two given identities are indeed special cases of the general conclusion we just proved. If n is 2020, you see the left-hand side is 2020 squared, and then plus the next whole number squared, and then plus 2020 squared, and then times the next whole number squared. And the right-hand side is indeed the same as the right-hand side in the given identity. Likewise, if n value is 2021, it's the same thing. We have 2021 squared plus the next whole number squared, and then plus 2021 squared times the next whole number squared equals the right-hand side of the given identity.